Hello everyone. Today in this post we are going to talk about the cross product of two vectors. That means we are going to multiply two vectors and the resultant is also going to be a vector. As I told earlier, vector products are of two types, dot product and cross product. When you when you multiply two vectors, if you get a scalar, that's called a dot product or scalar product. When you multiply two vectors, if you get a vector, that's called as a cross product or vector product. So if it is shown with a symbol cross. Say for example, I want to find out what is I bar cross I bar is how much. So I can write I bar modulus of I bar and the sine angle between them. It is going to give you only a magnitude of the cross product of two vectors. I know that the magnitude of the unit vector I bar is 1, next is also I bar 1, and they are in the same direction, therefore theta is 0, but I know sine 0 is 0, therefore the answer is 0. I can say therefore similarly I bar cross I bar or j bar cross j bar or k bar cross k bar is equal to 0. Suppose I am interested in finding out what is I bar cross j bar, then I can write I bar is 1 magnitude, j bar is also 1, and the sine angle between the x-axis and y-axis is 90 degree, but I know sine 90 is also 1, so so that is 1. Be careful, it's a magnitude I got, magnitude of I bar cross j bar is equal to 1. But being the output is a vector, it's not only going to have a magnitude but also going to have a direction. To find out the direction, we have a rule called thumb, something like a right hand thumb rule. I can use the rule to find out the direction of the cross product of the two vectors. It simply tells you that if there is a vector a bar, if there is another vector b bar, and I want to find out a bar cross b bar. So I have to put my right hand in such a way that I am curling my fingers in such a way that I am folding my fingers from a bar to b bar. I have to curl my finger from a bar to b bar. Then the direction of the thumb gives the direction of the vector. So this is the direction where I have folded my fingers from A to B. This is the direction of the thumb which is perpendicular to the curled fingers A bar cross B bar. So that will be the direction of obviously A bar cross B bar. So or we can use some another rule like let us consider that this is A bar, this is B bar, vector 1, vector 2. I want to find out the direction of A bar cross B bar from A to B. Then we can consider a screw with a big head. Let us say this is the head of that screw. Nail, these are the screws. So let us rotate the head from A bar to B bar, just like this, A bar to B bar. And it's very clear that the tip of the nail will be moving in the perpendicularly opposite direction. That's the direction of A bar cross B bar. So it's very clear to tell you that A bar cross B bar is a vector which is going to be perpendicular to A bar and is also going to be perpendicular to that of B bar. So if I have taken I bar cross J bar, the resultant has to be a unit vector, as we have already proved it is equal to 1. But it has to be perpendicular to both I, that means along x-axis, and perpendicular to j, that means along y-axis. That's nothing but equal to k cap. This is how I am going to find the direction of the cross product of the two vectors. That implies I can say I cap cross j cap is nothing but equal to k cap. We can follow the same rule to identify all the cross products. So we can simply say like the other way, like this. There is another way of saying it. Let us just consider a circle. Say this is I cap, this is j cap, this is k cap. Just now I have proved that I cross j like this is equal to the remaining k. Now I can say j cross k equal to the remaining I, or I can write k cross I equal to the remaining j. This is how I can simply find the cross product of the two vectors, right? I cross j equal to k, j cross k cross product of the unit vectors. Though I said cross product, I am right now solving only cross product of the unit vectors. Suppose if I have said j cross I, it will have the same magnitude of the k but opposite in direction as per the right hand thumb rule or a corkscrew rule. Or I can write k cross j, that will be I but in the opposite direction. If I write I cross k, that will be j but in the opposite direction. This is the basic rule that we can use to find the cross product of the any of the two given vectors, and the resultant cross product is a vector whose magnitude is a bar cross b bar is ab sin theta, and it has a direction, and its direction is found either using a corkscrew rule or right hand thumb rule, right? Thank you.